Good afternoon, friends. Today we are discussing the another new drugs, that is acetazolamide, or we can say Dimax. In your university exam, it may be asked like write the synthesis of acetazolamide, or we can say the write the synthesis for the Dimax. Both are the same, and the synthesis are the common. So you have to just remember the starting material and the product, and in between the reagents, which type of reagents give which type of product. If you are knowing the starting material and the product, so you will remember which reagent or react which reagent should be attached. So it will form our desired product. So first of all, we will discuss the mode of actions and their usefulness for this particular drug. So it falls under the cardiovascular drugs. So it is a carbonic anhydrase inhibitor with significant diuretic effects. The main use in the treatment of glaucoma. So basically, you have to remember that what do you mean by the term the glaucoma. So let's see. So glaucoma is basically an eye disease that causes gradual loss of sight in our eye. So it is basically related with the eye disease. It is used as a diuretic agent. It is used as a diuretic agent. Okay, so we will discuss their synthesis first. We are just discussing their mode of actions and their usefulness. So first of all, we'll discuss the synthesis. So here hydrazine hydrate. So hydrate means H2O molecule added. So we can say as a hydrate. Hydrazine, that is NH2. NH2 we are knowing it as hydrazine. Here two nitrogens and four hydrogens. NH2 NH2, two nitrogen and four hydrogen. Name is having hydrazine and having hydrate. So H2O molecule is added. So hydrazine hydrate is there. React with 2 moles of NH4SCN, ammonium thiocyanate. Thia means sulfur and cyanate means CN. Cyanate means CN. Thia means sulfur, ammonium, that is NH4. So 2 moles of NH4SCN. So hydrazine hydrate react with 2 moles of ammonium thiocyanate with the removal of ammonia. 2 moles of ammonia will be removed and we will get 1,2-bis thiacarbonyl hydrazine. So we will get it as a 1,2-bis thiocarbonyl hydrazine. So how it will be react? So we will just discuss. Okay, sure. Here is a hydrazine hydrate. So that means NH2, NH2, hydrazine, NH2, NH2. Here is having 2. Okay. So it is known as hydrazine NH2, NH2. So it will react with NH, 2 moles of NH4SCN. So here I am showing you NH4SCN, write it as C double bond S, and the 2 NH2 group will be like this. So NH4SCN, ammonium thiocyanate. So hydrazine react with 2 moles of 2 moles of ammonium thiocyanate. So 2 moles of ammonium thiocyanate, that means C double bond as NH2, NH2, 1 mole, and here second C double bond as NH2 and NH2. So from this NH2, here H and here NH2. So both will be eliminated like this and it will form as ammonia. So removal of ammonia will be there from the 1 mole of ammonium thiocyanate. So minus NH3 will be there. And here it is also H and NH2 will be removed. So second NH3 will be there. Minus NH3. So here basically 2 moles of ammonia will be removed, and here C double bond S is directly attached. See this C double bond S, this C double bond S is directly attached to this nitrogen atom. In the same manner, this C double bond S is directly attached, this C double bond S is directly attached to this nitrogen atom. As you are seeing in this mechanism, here hydrazine is reacted with ammonium thiocyanate. So hydrazine is reacted with 2 moles of ammonium thiocyanate. So we will be having two removing of 2 moles of ammonia will be there, and here C double bond S group is directly attached to this nitrogen NH group, ammonia group. Okay, this NH, this C double bond S group will directly attach to this. So because ammonia is eliminated, and this NH2 group and this NH2 group is as it is like this. NH2 and this NH2 is as it is like this. Okay. So they will see further on what should be having. Okay. The next step is this C double bond uh, here, the C double bond S group will shift its electrons to this CN bond. So we will be having this double bond here, and here it is, here hydrogen is shifted over this sulfur atom. So here we will be having SH group like this, because we are shifting this electron here, so it is having a positive charge like this. It is having a positive charge like this. So to neutralize, H will give the electrons like this. Okay. And here sulfur is having negative charge because it giving its electron. So it is directly attached to this hydrogen and it will be form SH. Okay. So this NH2 group, and here in the same manner C double bond S will react and shift its electron to carbon nitrogen single bond, and it will form the double bond like this, and this hydrogen is shifted towards this sulfur atom. So SH and here NH2. So here also ammonia group will be eliminated like this. So here basically a cyclic ring will be formed between these two, this having directly attached to the sulfur, and this side is also directly attached to the sulfur. Okay. So we are just giving the numbering like here. We are giving the numbering starting from, always start from sulfur. So sulfur, then second number carbon to this sulfur, this carbon having SH group, third number, fourth number, and the fifth number. Okay. So you will clearly understand the 3 moles of ammonia will be reduced. So here the shifting of hydrogen will take place, this sulfur atom as we are discussing above. So 1 to bis thia means sulfur, having the carbonyl hydrazine. So basically this structure is known as the carbonyl thiocarbonyl hydrazine. Okay. And then after here NH3 group will be removed like this. As we are discussing above, this NH3 will be removed like this. This NH3 group will be removed like this, and having a close ring structure, having sulfur containing 5-member ring. Phosgene, or you can say cyclization minus NH3 group is there. So here we are just numbering over here. So starting from sulfur 1 number, 2 number, 3 number, 4 number, and 5 number. So five it's having amino groups. So 5 amino, 2 mercaptose. 2 mercaptose. That means carbon having SH group. So it is known as mercapto group. Having, so prefix is mercapto. So 2 number carbon having mercapto group. So 2 mercapto, 1,3,4 thiadiazole. 1,3,4. So that means 1 number sulfur, 3 number nitrogen, 4 number nitrogen, and having 5 number ring. So it is known as diazole. So thiadiazole. So 5 amino, 2 mercapto, 1,3,4 diazole. The next step, the acetylation reaction takes place in the presence of CH3COCl. So here Cl group will be removed, and here like this. So Cl group will be removed, and here had just as we are just discussing. Okay, I am just writing over here, so you will get the basic understanding what we are explaining or what we are seeing in the structure. So I'm just writing the CH3COCl. Okay, so CH3COCl having here NH2 will be there. Here NH2. This I'm writing over this NH2. Okay, so this NH2, this NH2 I'm just showing like here, and then this carbon as it is, this carbon. So this removal of this HCl will be takes place minus HCl. We are writing over minus HCl as it is, and you are getting CH3CONH. So you are getting CH3CONH group as it is. So amide group will be there. NHCO CH3 amide group will be there, forming an amide group. Then after here aqueous Cl2, or we can say oxidation takes place. So Cl will be there, and this sulfur having attached with hydrogen, so H will be removed, HCl will be removed, and S sulfur having Cl. So here the oxidation takes place. So that's why it having SO2Cl group here attached. So because here we are, if we have methyl group, so yeah, it will be oxidized with the and we will get carboxylic acid. In the same manner we are having a sulfur group, so we are oxidized in the presence of Cl2, so it will convert into SO2Cl as an oxidation product. So 2-sulfonyl chloride, so here SH will be converted, here HCl will be removed like this, and this Cl, so it having a oxidative property, so it oxidize sulfur with the, so it will convert into 2-sulfonyl chloride derivative. Next step, it is amidation. Amidation, that means insertion of amine group in a particular reaction. Insertion of amine in a particular reaction, it is known as amidation reaction. So here NH3, we are just taking NH3. So I'm just writing HNH2. Here ammonia in the presence of ammonia. NH2H, so it is basically ammonia. So H and Cl will be removed like this HCl. And here it is having SO2 and NH2, because this NH2, and here this H will be there. So here HCl will be removed like this. As I'm mentioning over here, both are same. So amidation minus HCl will be eliminated, small moiety, and we will get acetazolamide. So basically amide group is there on the both side. Amide group it is there. So it is a synthesis for acetazolamide. or we can say Dimax. Both are same. If you are asking in university, write the synthesis of Dimax or write the synthesis for acetazolamide. Both are same. Both mode of actions and uses both are same because the synthesis are common. Because acetazolamide common name known as Dimax, so both are same. So thank you so much friends for listening me. Stay tuned for the next video. If you like this video, please share to your needy friends so they will also clarify their concepts and in better understanding for any particular type of drug synthesis. So thank you so much friends.